Okay, good morning, everyone. So today's lecture that we are doing is the continuation of what we did yesterday. Today we are doing text representation in NLP again, and we are continuing today on term frequency, inverse document frequency, and n-gram. So why this term frequency and n-gram are very important? Because sometimes what happens is your LLM, it tries to hallucinate. It gives you a lot of errors after parsing. And how do you measure your errors when LLM hallucinate? So we will learn that. And after learning that, we should be able to do some projects where you are parsing your text and you can measure it either by term frequency, inverse document frequency, and by n-gram, that how is the accuracy of the parsing text versus the actual text. Okay, let's learn these two concepts today, and then we'll talk about more. Okay. Okay, guys. So in the yesterday's lecture, what happened was we learned something, that what is one hot encoded. Yes. What is one hot encoded? What is bag of words? So what you learned was that you can represent a sentence like this: I love cats, by this this thing like here. So you have I love cats, and you saw that it is represented like this. It is representing here by a bigger matrix, and this is how your sentence looks like. Whereas your I love cats in a sentence, it looks like this here with a bag of words. You further, shrank it in only one row. Now, for term frequency and inverse document frequency, this is how your vector looks like, where you have given it, more weightage to some words, and you see some words, it is not even giving any weightage, right? And then you have something called n-gram, where what you see is now your vector is even bigger than a vocabulary size, right? So this is how, we see that text can be represented. And to some people, if it looks like this is, why do we need to learn that, guys? When your LLM will hallucinate, you have to come back to these techniques to verify how much error LLM has produced, because here I'm not using LLM to solve the same problem, right? And this is number one, one way to measure the problems. Okay, let's understand it. Okay, so here we have two things. One is your term frequency, inverse document frequency. Now, what is a term frequency? So guys, in bag of word model, we just took, your corpus, we have words, and then the words gave it, we start giving your binary one or zero to your words, and we made a vector. But in term frequency, what we do is we do something called, we start weighing the importance of each word. Okay, and then in inverse document frequency, we further refines the representation by reducing the weight of the words. So for example, if now I am creating a word embedding out of, for example, any sentence, I will start giving the weightage to that. For example, if this is my entire screen here, and this is my text here, that I want to put it in embedding. So what are the key important words here? The key important word here is term frequency, inverse document frequency, sentiment analysis, and spam detection. So out of this entire text, these are the words where, you will give more importance to your you will give more importance to these words into this entire text. So that is where we have something called, meaning we are giving the importance to each word in a document, and we will learn now in the next slide. So let us see here now. So for example, we are still doing the same thing, that is a spam classification. You can also do here text classification, and you can also do here other, spam classification, text classification, topic modeling. We're using the same approach. Having said that, it means if you have, tomorrow policies coming to your company from different vendors, then you are able to simply segregate them using these kind of techniques. So let us see how do we build that. Now we have here, a corpus. So in the corpus we have something called, we have three data sets. We have win a prize now, claim your prize, and you have won a reward. So you have these three corpus. Now what happens now? So first of all, one thing intuitively you have to see that for term frequency, inverse document frequency, each of this thing is document 1. This is document 2. And this is document 3. Right? Document 1, document 2, and document 3. And now what happens here? Now, after you have these 3 documents, so this is a slight confusion to everyone, because this is term frequency, inverse document frequency. This is also your, data, but each data is your document 1, document 2, document 3. Now, yesterday we learned that this will be your vocab size of each document. So the vocab size here will be win a prize, now claim you have won a reward. That means all the words here, they go into the vocab. Now, how do you calculate term frequency? So we are calculating here something called term frequency, and then we will calculate something called inverse document frequency. Now, what happens in the term frequency here is, in the term frequency, okay. So in the term frequency, guys, I am calculating the term frequency for a line which is called win a prize. So what happens in win a prize? So in win a prize, what is happening is, you see how many times this word is appearing into this sentence itself. So it is appearing, win is appearing 0.33, is appearing 0.33, prize is appearing 0.33. So this is win a prize. Now and other things here in this line, they are all 0. So 1 by 3 win, because there are 3 words, 1, 2, and 3. So win a prize is having, appearance of 1, 1, and 1. In claim your prize, it's also becoming here, claim is 1, your is 1, and prize is 1. So this is also becoming claim your prize, right? So this is now your, this is how your term frequency is, right? So term frequency basically tells you how much time this word is appearing within itself, or within one document that you call, because now this is your document, or within your one data set. Okay, now let us see here, how does your inverse document frequency works out here. And this is very, very important concept. When you build your models, you will be using this technique to understand where the LLM has hallucinated, and how are you, checking everything. Now, in the inverse document frequency here, what is happening here is, you have to check, see, this is inverse document frequency. That means how many times this word, that is win a prize, was appearing now in the entire vocabulary that I have. So this was my vocabulary. Now I see here win a prize. So win is appearing 2 times. So this is appearing 2 times. Is appearing 2 times. So this is appearing 2 times. And prize is appearing 2 times. So this is appearing 2 times. So win a prize, these are appearing 2 times. So this is here is your win a prize. And now you see here the frequency should be 2. 2 out of how many documents we have? 3 for win. So win is coming 2 times and it is appearing in 3 documents, 1, 2, and 3. So it becomes 2 by 3, right? Now, similarly, is 2 times, 1 time here, 2nd time here. So 2 by 3. Prize is also appearing 2 by 3, right? So this is everything. Now, this 2 by 3 is now I'm doing inverse of it. So I am doing here 3 by 2. And why I'm doing 3 by 2? Now you will see this word here, 3 by 2, because I am trying to analyze if win a prize doesn't appear multiple times in the document. If it is appearing multiple times, this word is not important, right? For example, in this document, the line that I have in front of you, you have the so many times. I don't care about these words. So anywhere my word is appearing multiple times, I want some kind of weightage that reduces it into the entire thing, right? So that is how the inverse document frequency is trying to reduce the weight or the importance of the words that are appearing again and again. For example, if here is a word, comes again and again here, again, in the corpus 4, in corpus 5. So what will happen? This word will become here 6, right? And then this number is further reducing. So this number will become 6 by, it is the entire document. It has appeared, if this is the number of document will be 6, and maybe it has appeared 24 times, right? And this is how I'm reducing the number. So overall, I think if it made sense, we calculate term frequency. Term frequency is calculated within 1 sentence. Inverse document frequency take care of the entire vocabulary, which will be here, that how many times the word has been repeated. And now, looking at that here, we saw that we have a score. We have a score here. So this is, guys, your term frequency. This is 0.3333. Your inverse document frequency here is 0.176, 0.176, 0.176. And if I multiply them together, then it becomes my net frequency, which is here. I have multiplied them, and they become 0.059, 0.059, and 0.059. So your document, your entire vector becomes like 0.059, 0.059, and rest of the words, because they had a 0 present, so this is all 0 here, right? Win a prize. So this thing, your TF-IDF is multiplication of your term frequency, your inverse document frequency, and your term frequency was 0 for all these words, because here we are just considering win a prize, and inverse document frequency is this, right? And together they give something like this, right? So this is how this entire term frequency, inverse document frequency works, right? Okay. You have any question here, how it is working? I am happy to answer at this stage. Now, guys, I'm open, for your comments in the chat. Okay, sorry about that. Okay, it has cleaned up. Okay, guys, so you have something called win a prize, claim your prize, right? So win a prize looks like this. Now, claim your prize, it will look like this, right? Now, why is now, you see one thing that is very important, right? Here the word claim has 0.159 as the score. Win has a score of 0.059. So what do we learn here from this thing? Anything which has here, so for example, here win is missing. It was there in the previous text. And this was the extra word. It's a typo here. So for example, the word that is a claim here, it is coming only once. That's why it has a higher score, right? And that's why it is highly likely that this word, it is classified much more faster because of a higher score. Wherever the win has got a lower score of 0.059. So this has a poor score, right? So it has a less chances of getting classified. So claim and win here, they have different scores. Okay, so I hope this is clear now how this term frequency and inverse document frequency works. So in the term frequency, you are just measuring the frequency within the document itself. And in inverse document frequency, you are measuring the frequency within the entire corpus. So if the entire corpus has a lot of win words, this number will keep on becoming smaller and smaller. We don't care about this word. For example, the words like the, and, your, yours, we don't care about these words. That is why, you see that those words have given a very, very less importance. What is important here was claim because it only appeared once, right? Now reward would be equally important here because the weightage that will come after you multiply its frequency within this document, you have won a reward versus into this entire document will be very, very high. So this is how you give more importance to words which are rare or which are unique. And that is why this concept of term frequency and IDF is a very solid concept. When your LLM hallucinates, you have an output, you try to generate the embeddings, and now you compare those embeddings with TF-IDF, and you can literally come at some numbers where you can tell them how much LLM has produced new words. So this is, we have been developing it. Okay, so any doubt here, guys, you can ask me. Some interaction is always very helpful. Okay. So guys, here, now, what has happened here? So guys, yesterday we did this code and I was running this code that delayed the class. I can run it again with TF-IDF and will tell you, where is the difference. So here, guys, we are importing key libraries here, sklearn. Then we are importing libraries like pandas, matplotlib, and cborn. These are these different libraries I'm importing. And now we have the messages here that I want to classify into spam or ham, right? Now, this is the data set that is provided. So you can download this kind of data set from Twitter, you can download this kind of data set from a lot of links I can provide, and it is already provided in the code. Now, what do you do is you use this term called TF-IDF vectorizer. Now, this is an inbuilt function that we have from sklearn library. You see here, I'm importing this function. Using this function, we can actually determine the weightage of each word within the sentence and within the entire corpus, right? And after that, once we vectorize it or count it, as the one I calculated here, 0, 1, 0.159 and 0 and 0, something like this will be the entire vector. Now, after this vector, we can transform it. Now, this function will put this into this vector. And now what I am doing here is I have something called xtrain. I will divide this data into train and test. Then I will divide this data into train and test. And we are splitting it here. So this entire data that I have, that I told you yesterday as well, we have, train and test. So this is a very common thing. You will have, hundreds of data, hundreds of Amazon reviews that you can classify as good or bad, or 100 of messages, out of which, if these are 1 and this is 100, you have to classify some of them as train and some of them as test, right? So this is your train data set and this is your test data set, right? Now this train and test, and this is your X train and this is your X test. And they will also be attached to a particular label, which will be your Y train and Y test, right? So this is the fundamentals of doing this work. And I'm re-emphasizing it because right now, this is your second week itself, and I'm trying to build some important concepts, which are very, very important, right? So after that, I build here Y train and Y test. And now I'm splitting it with a test size of, 0.7 that I can change. I can put it 0.1, 0.2, 0.3. After that, I have divided this entire data set. Now what I am doing, I am calling a model called naive Bayes model, and I described in yesterday's, it's the same thing. We have generated embedding using TF-IDF, but for naive Bayes, how is this working? I would say that go to the video recording of yesterday, that how naive Bayes is working. Basically, it is just trying to calculate the probability of words. And it is trying to calculate the probability of word in the spam and then the probability of spam itself. And then you use this called model fit. Model.fit, it fits your X train with Y. So right now your model is learning. So if your first message is a spam, it is trying to fit it with a label called spam. If your second one is ham, it is trying to fit it with a label called ham. Then it is trying to fit it with a label called spam, the third one. So this is in model.fit, right? And now your model has trained itself with only 2 lines of code here, right? After it has fitted, now you can predict the accuracy of the model. Now the accuracy is here. This is the accuracy. So you do the accuracy on your test and predict it. That means the data that you have, you have left out of your 70, like if it was 100, your 70% of the data, you put it on the train. 30% of the data, you have it on test, and there you are testing your training. And this is how you are predicting it here. It makes sense. This is all new to you, but should be making sense, and you have to do and develop a lot of projects here. This is the key of everything. And after that, you can have the feature names out. Right? So guys, again, very thing. These are only 4-step codes. You convert into the embeddings. You split your data. After splitting your data, you fit your model using the choice that you have taken, and you calculate your score on the splitted data from 1 to 100 to the last 30% of the data that is left. That is your test data, right? This gets trained on 70% of the data, and you make these prediction on them, right? And then here I'm just printing my embeddings here, right? Okay, I hope this made sense. I explained yesterday as well, all these things. Okay. Now, if you remember, see how simple is the how simple that with even with a single code you can do so many good things. So yesterday was our code like this. So this is the same code of yesterday where I have was doing with bag of words model, and in the bag of words model I have something called vectorizer here, and you see here in the vectorizer I use a function called count vectorizer. And here I am using a function called TF-IDF vectorizer. I'm also calling this thing from sklearn yesterday. This thing also I'm calling it from sklearn today. All these functions are available in sklearn. And this is your TF-IDF vectorizer. And this is here is my count vectorizer. It's the same thing that is we are doing with a little change that I have called here a different embedding. I hope it made sense. Rest everything is same. I divided it here. It's 0.1. You can choose the number. It's like dividing your entire data set of 100 messages into 90 versus 10 or 70 versus 30. That's what you do here, right? And this is a random state, right? And you can do and run these codes. And finally, that yesterday I showed you a lot of places where running the code where you can actually put your messages in, and it was classifying it for you. Any question here, guys? I'm happy to answer. Okay. So guys, with this thing, now here, let us quickly see that this is the same thing, and your vector look like this for TF-IDF, whereas for your normal bag of vectors, your vector look like this. And we can quickly check in the code as well. Now, here in the code as well, so what is happening in the code? So in the code itself, if you go here, I did here your code for, this is the bag of words code, same code. Now here. So guys, we are doing the same thing. As I explained to you, what I'm trying to show you is a TF-IDF vector here. That is the function that I introduced. And you can go at yesterday's video to see in detail how I played with different, functions, and we were playing with it. But today you see here with this TF-IDF vectorizer here, we are getting here your number of TF-IDF value. So we have a win a free iPhone now. So you have win a free iPhone now. So win free iPhone now and free iPhone here. So one thing is very, very important here. We are using something called ngram, and I will show you. And this code now will be something with something like we did it with one word. Just a second. Yes. So this is just coming up in the next slide. How does the ngram works here? Now here, this is the code I ran, and you see the values of, win a free iPhone now, win now iPhone free. All of them has a value here. And the value of congratulations, 0.659, was only a word. Congratulations was a different, and it has given it a higher value. Congratulations. You have won. So congratulations, has the highest value, 0.659 among all. Coupon was one word here. If you see, this is your entire vocabulary. Now coupon here is a one word, and coupon has the highest importance here, right? Versus compared to what we did yesterday, in the bag of words vector, we had vectors like this, right? So this is where the thing is. Okay, now after that, let us go back. If we have got the main idea out of this. Okay, now we will learn a last form of text embedding, which is your n-gram, which is very, very important. I think TF-IDF and n-gram, I am doing so many projects with the industry right now. And this is where we are able to identify where LLM has done mistakes. Because with these techniques, you can go and easily backtrack. What LLM gives you, you won't be able to backtrack. So you have to use LLM, but to verify it, you have to use this technique. Otherwise, you don't know how much error LLM is making out, right? So now let us see what is unigram, what is bigram, and what is trigram. So in the unigram, what happens? How are the embeddings made? So the word, here, the small diagram should be clear. In the unigram, this is big data iBook. In this is big data AI book. You have something called, where each word has a separate embedding. Each of them separate embedding. Whereas this is big data iBook. Here, has a separate embedding. Isbig has a separate embedding. Big data has a separate embedding. Data I has separate embedding. AI book has separate embedding. Now, trigram, here, this is big. We have three words have a separate embedding. Is big data has a separate embedding. Big data AI has separate embedding. Data AI book has separate embedding. Now you have these three. Now with this thing, you can see within a sentence itself, you can, take words like this. This is big data. Then you have is data big. Then the third embedding is big data AI. Then the fourth one is data AI book. So these are the different word embeddings that we can create. Okay. Now here, what is now happening? So guys, this is very important. And as you saw, my TF-IDF, importance changed when I changed it. Now this is a sentence here, win a prize now, claim your prize, you have won a reward. I am keeping exactly the same corpus since yesterday, so that, we build slowly and try to compare it. Now here, you see here, what is happening here. So here, the winner prize one is the normal one. So the vector is a normal one that you have been doing since yesterday. 1, 1, 1, rest is all 0, right? Claim your prize. Here, claim has one thing here, your has here, and prize has one. And this is, you have won a reward. This is here, right? Now, do this. And now with bigram and tokenization and embedding, what is happening here is, with bigram, you are using here win prize now. So here win has together one embedding, a prize together has embedding, prize now together has embedding. See, now your embeddings, they are trying to have the context, win is attached to A is attached to price is attached to now. So your now meaning is preserved. Now you have these two words together, Wherever they will be seen, there will be an embedding, corresponding to that. Claim your, here is an embedding here. Your price, here is an embedding here, right? Similarly, you have won a reward here. And this is how, your entire corpus is created, or is how to say, is parsed, or you can say, it's divided into. Similarly, you have this thing now, win a prize now, right? Now here, this is here, win a prize. Now you have something called win a prize now by gram. Now look at trigram. Guys, win a prize now, here itself in the trigram, win a prize has a one thing, complete win a prize. Now our prize now was a second one which has one, right? Claim your prize here, entire thing has one. You have won, entire thing has one. So this is how the embeddings are created in trigram. So you imagine a big Wikipedia, wherever these lines are repeated, it will, start giving importance to that, right? So this is the difference between unigram, bigram, and trigram, where in one word I take win, in this I take win a, and then my second embedding will start from the second word, a prize, where, and in win a prize now, all my embeddings start from here. Win a prize, and then the second one will start from a prize now. Claim your prize, and this is you have won, right? So this is my three things here. Now, guys, in the n-gram here, it's the same thing that I showed you. What is changing here? A function is changing here. So the function that again we are importing from sklearn, we are importing the same function, but in your here we have something called n-gram, because you combine here TF-IDF with n-gram, because now you can see when I do 2 by 2, that means I'm doing bigram, so it should take a window of words and then slide. So actually it takes a window of words and slides, and rest my entire code is same. How cool is that, right? So I can quickly compare them using these functions and can have values. Now, after that, let me do this very quickly for you. Okay. So guys, here you have your 1 by 1, right? So 1 by 1 is unigram. That's why it became like this. One word, each word has, the importance. Now let me do by 2, 1. That will change, unigram to bigram. All right, let me do 2. Now see here, this will change. Now you see here, meeting at 5 p.m. today. So at p.m., this is my weightage. Meeting at, this is my weightage. p.m. today, this is my weightage, right? Congratulations, you won. Congratulations, you have the weightage. You won had a weightage, right? Okay. So this is the important thing. Now, I will give you an exercise today, a little bit. So, okay. Do you want to also see how does 3 by 3 does? in this one. Look, let us quickly see how 3 by 3 does. I'm just changing from unigram to bigram to thing. 3 by 3 further changes. Now we have 3 words together, right? And this is how the entire importance changes. Now you start building a real life projects with me now, because this is extremely important what we did. Just a second, guys. So guys, now what you will do is, this was your thing that, now what you do is, you go on internet and you are building something, an AI agent. And to do that, this AI agent, for example, we have Air Maison here. It will, will do a PDF policies from PDF. So it will extract the policies from PDFs that, they have it from different vendors. And then they will use this policy, they will extract it from, different PDF document. And they will use LLM for that, as they are already, one of them told that in the other class that they used O5 or, ChatGPT O. And they will use ChatGPT O, they will use ChatGPT to extract it. Now, what LLM will do, it will generate words, because we wanted exactly that, you have to extract some policies from the PDF. LLM will extract it and it will start, because it is LLM, so it will introduce some words. This is the nature of LLM. So for example, if you are, trying from internet, trying to extract the information, then it will add some words there. Now you have to build a model comparing what ChatGPT has produced versus what was in the original PDF. And you have to compare it using n-gram. This is the only technique that you will be able to compare it straightforward. That what is the data that ChatGPT has produced versus what is the data was original in the PDF. And you compare it using n-gram. And this will solve, very important problem. So this thing, I think South can do, because he is from Air Maison. But for other people, what you can do, guys, is you can, build a small project, take some data from Twitter, and I can give you some links, and you will have a lot of messages, sentiment, good tweet, bad tweet, sad tweet. And then this will be your data set. And after that, you can compare this data, and build the model with n-gram to classify these sentiments. And this is the kind of activity that we should be doing, and it will exactly use the same code that I have right now in front of you. Just that it will have a different data, and in position on these places. Sorry, here on these places it will have different labels. It will have labels as good, bad, and sad, and here it will have all the messages from Twitter, right? And you can simply classify them, and this gives you a model instead of spam classification, sentiment classification. But for engineers that are coming from Air Maison here, I would say that have your policy parser, have it parsed by LLM, then compare it with using n-gram. And you will see that how much mistakes it has done, and then it will give you a percentage and an ability to improve your prompts. So this is what I wanted to, do the project. Okay. So having said that, let us continue here. Just, and I try to finish here. So here we have compared, our different text embeddings. These two are most, popular here, TF-IDF and Ngrams. And bow words is something when you have a large text, but these two are very efficient in a lot of all these things that we do: text classification, sentiment analysis, search engines, spam detection, and topic modeling. And you can do all of these projects. You can do all of these projects using these things that I told you with very, very simple codes. And you can solve a lot of problems. You can classify the text, you can analyze the sentiments, you can, go on search engine and, you can create a small search engine, because TF-IDF will start giving importance to words. So the words which have more importance will appear first. Then you can do spam detection, then you can do topic modeling. And the code that I gave you, that can be transformed into multiple different projects. Now, we will do one small thing here. There's a very, very important thing that I should be doing. Here is code on named entity recognition, that is NER. Now, what is named entity recognition? Now, you have, your policies again, because coming from company, say, REI. You have a name company coming from, say, Apple. And here is the name of the CEO of Apple, right? And here you have Google, and you have a name of CEO, Sundar Pichai, right? And now you want, this is all your text from internet. This is all the text, and you are something doing named entity recognition. What does that mean? It means that I run a simple code and able to detect which entity these document belongs to, right? Let me see here, and it's a very, very important code. Now here, for example, what is happening in a name entity thing? For example, it is a fundamental task in NLP where we are able to identify and classify entities. So we are able to classify the person, location, organization, name and date and time, and product's name. So this thing you are able to do it if with this 4 lines of codes. So what I'm doing is I'm importing spaCy, and I'm importing a pre-trained model here, spaCy load. And after that, once I upload the spaCy model, then they are doing what I'm providing this sample text here, and you can put your document worth 2000 things, and I am asking it to put it, because here I defined a function NLP. I am putting my text into this function, and I'm just asking this model to give me this entity. Now I'm just running this model on this function, that is running this document on this function NLP text, and it is able to tell me as an output, it is Barack Obama, that's a person, that is Honolulu, that's a place, and then it's a GPE. This is all the positioning, right? And it is able to tell me this text. So this is a very, very important code where we can do name entity recognition using some pre-trained model. I have a big text, and I'm able to tell you where each text belongs to. Now, in spaCy itself, you have something called person. I give it entire entity. It will also be able to tell me geopolitical entity, organization, date, time, monetary value, location, and product. So it will also be able to tell me if it is coming from REI. Okay. And it will be able to tell me it is coming, what are the money in it. Also able to tell me the date, the cities, everything. So this is one way that this kind of code is known as name entity recognition. Very important. The cybersecurity company I was working with, we were building a product where we kind of install name entity recognition code, where any company who was putting the data in, we were immediately able to label it with this simple code of name entity recognition. And for example, here you can build, with this thing, your codes like customer support, news aggregation, and medical application. And these are very simple thing. And you can extract people, places, organization. Immediately the data come to your pipeline. It is all getting highlighted. And this is what we known as NER. So guys, with this, I finished today's lecture. I hope you enjoyed it. And these are some of the libraries that you can use: spaCy, NLTK, most famous one. Then you can use here Hugging Face and Custom Core NLP, Stanford one is good. And these are different libraries that you can use. Okay, guys, I have I think covered most aspects of it. In the next meeting, I will cover glove and word2vec. Now we are coming more to the predictive technology, where we cannot really understand what is going inside the LLM. I'll try to make it simple, but it is becoming more advanced. And today is the second week, and I think from third week itself we are leveling up. Okay, with this I think I will say goodbye and see you tomorrow. Bye bye.